Hello dear students, welcome to your chemistry class. So today we will discuss a new chapter 4, chemical kinetics. In our last class we have completed chapter 12, aldehydes, ketones and carboxylic acids. So from today we will discuss chemical kinetics. So at first, the branch of chemistry which deals with the study of rate of reaction, and after that factors affecting rate of reaction and mechanism by which a chemical reaction occur is called chemical kinetics. So in chemical kinetics generally we will discuss the rate of chemical reactions, after that the factors which affect the rate of chemical reaction, and then the mechanism of chemical reactions. So then, before going to study rate of chemical reaction, let us discuss types of some chemical reactions. So there are generally three types of chemical reactions on the basis of their rate. So the first one is fast and or instantaneous reactions. So these chemical reactions take place within 10 to the power 12 seconds. Okay, that means these chemical reactions are very fast. They are generally ionic reactions or organic substitution reactions, and then there are some chemical reactions which are very slow, and to complete those chemical reactions several years are required, or from some minutes to several or some years are required. For example, rusting of iron, okay, then transformation of diamond. And there are some chemical reactions which are generally moderately slow, okay, and these reactions are in between fast and slow reactions. So now, on the basis of the different type of chemical reactions, now let us discuss rate of reaction. So rate of chemical reaction means the change in concentration of any one of the reactant or product per unit time. So rate means change in concentration with respect to time or per unit time. So the unit will be mole per liter per second, okay, or mole per liter is also represented by capital M. So molar per second, or in case of gaseous reactants, ATM per time or ATM per second. Hence, let us now discuss the rate of chemical reaction. For this reaction, suppose A and B, they are reacting to give C and D, and their coefficients are small a, small b, small c and small d. Okay, now if we consider a bigger time interval, then that rate is known as average rate. Now suppose the change in concentration for A is delta A, okay, and the time taken is delta t. So in this case, delta A by delta t is rate of disappearance of A, okay, and since the concentration of reactant always decreases within a reaction, therefore we have to multiply the negative sign before this rate. Again, when we will consider the reactant B, then rate of disappearance of B will always disappear, okay. Rate of disappearance of B equal to minus delta B divided by delta T, okay. Again, in the chemical reaction, the C will appear, hence rate of appearance of C when the change in concentration is delta C, then delta C divided by delta T. Delta T is the time taken. Again, rate of appearance of D equal to delta D divided by delta T. So these are the rate with respect to reactants and products. But when we will consider the overall rate of the reaction, then in this chemical reaction, since the coefficients are not equal, therefore we have to divide each and every term with their coefficients. So to get the equal rate, always remember when the coefficients are not equal, then minus 1 by A dA by dt, again equal to minus 1 by B delta B by delta T. Okay, again equal to 1 by C delta C divided by delta T, equal to 1 by D delta D divided by delta T. So to get equal rates for the reaction, you have to always divide the rate with respect to each reactants and products with their coefficients. So very easy. Rate of reaction means the change in concentration of any one of the reactants or products per unit time. When the change in concentration is delta A and the time taken is delta T, then the rate means delta A by delta T. But in case of reactant, you have to multiply minus before the rate. Again in case of products, since product always increases, therefore the rate is always positive. Okay, and then to get the equal value for each and every rate, we have to divide their expression with their coefficients. Now earlier we have discussed about average rate. For when the time interval is large, then it is called average rate. But now let us discuss instantaneous rate of reaction. So when rate of a reaction is determined for a particular moment of time, then that rate is known as instantaneous rate. Okay, now suppose we have a chemical reaction. In this reaction, reactant R is converting into product P. Okay, and in this case, the average rate will be, in this case this one will be AV, average rate equal to minus delta R by delta T. Okay, again delta P by delta T. Okay, now when we will consider a particular moment, then the difference will be very small, and in this case the delta is replaced by D. Hence the instantaneous rate equal to minus del dr by dt equal to dp by dt. For average rate, you have to multiply, or you have to take delta, and for instantaneous rate you have to use d. Okay, and after that, always remember, when the delta t tends to 0, that means when the time difference tends to almost 0, that means when the time difference tends to a particular moment, then the average rate will always equal to instantaneous rate. Okay, now let us discuss different factors which affect the rate of reaction. So the first factor is nature and concentration of reactant. So always remember, when concentration of reactant increases, then rate of a chemical reaction always increases. Okay, and after that, the next factor is temperature. So for every 10 degree rise in temperature, the rate of a chemical reaction always or almost become double. That means suppose we have a chemical reaction which is taking place at 25 degrees Celsius. So when the temperature will become 35 degrees Celsius, then the rate of the chemical reaction, that means the change in concentration with respect to time, will become almost double. Again, the next factor is surface area of reactant. So the rate of a chemical reaction generally increases with increase in surface area. Okay, after that, radiation and catalyst. So in presence of catalyst, the rate of a reaction always become faster. Similarly, in presence of sunlight, the rate of some chemical reactions become faster. So the next factor is pressure of gas. So about pressure of gas, you have already learned in class 11. Okay, so that means there are some methods in which we have to use temperature and pressure. So when pressure of a reaction increases, then rate of a chemical reaction may either increase or decrease according to Lesch-Delius principle. So about that you have already studied in class 11 equilibrium chapter. So these are some factors which affect the rate of a chemical reaction. So the first one is generally concentration of reactant, and after the temperature, after the surface area, and then catalyst. So these are four main factors which affect the rate of a chemical reaction. Now let us discuss rate law expression. So suppose we have a chemical reaction, this one, reactant A and B, they are reacting to give products and their coefficients are A and B. Okay, now we have seen that the rate of a chemical reaction, is directly proportional to concentration of the reactants. So in this case, rate is directly proportional to product of concentration of the reactants, okay, to the power their stoichiometric coefficients. And when we will replace the proportional sign with equal sign, then we have to multiply K. Okay, therefore rate is equal to K into concentration of A to the power A, concentration of B to the power B. These are their stoichiometric coefficients, and this expression is known as law of mass action. But now we have to consider the rate law expression, and in case of rate law expression, rate is directly proportional to concentration of A to the power alpha, concentration of B to the power beta, or concentration of A to the power x, or concentration of B to the power y. We can use, or we can replace the alpha and beta with x and y also. In this case, alpha and beta are experimental terms. Okay, they may or may not be equal to the stoichiometric coefficients A and B. Okay, and this term, that means the square bracket of A and square bracket of B, they represent the molar concentration of A and B respectively, and K is called velocity constant or rate constant. Okay, and this expression is known as rate law or rate law expression. Now let us discuss rate constant. So when concentration of both A and B equal to 0, then rate is equal to K. Okay, so we can define K as the rate of the chemical reaction when all the reactants have unit concentration. So always remember, when A and B both will become equal to 1, then rate is always equal to K, that means rate constant. Thus rate constant of a chemical reaction is rate of that reaction when concentration of all the reactants have unit value. Okay, and then the unit of rate constant, or it is also known as specific rate constant, and unit is always mole per liter, then 1 minus n to the power 1 mole per liter to the power 1 minus n, then second inverse. So that is the general expression for the unit of rate constant. And in this case, the sum of these exponents, that is alpha and beta, is known as order of this chemical reaction. That means alpha plus beta is equal to n. N represent the order of that chemical reaction. Okay, and when we are determining the unit of rate constant, we are considering mole per liter to the power 1 minus n. That n represent again order of the chemical reaction. Okay, so now let us discuss characteristics of rate constant. So first one is greater the value of rate constant, faster is the reaction. So for a particular reaction, the value of rate constant do not change. It only changes when the temperature of the reaction is changed. So when the value of for higher value of rate constant, the faster is the reaction. And then this reaction has a particular value of rate constant at a particular temperature. So about the second point I have already told. And then the value of rate constant for the same reaction changes with temperature. Okay, we have already discussed that for every 10 degree rise in temperature, the rate of a reaction almost become double. Hence, the rate of a rate constant for this reaction only changes with temperature. After that, the fourth point is the value of rate constant for a reaction does not depend upon the concentration of the reactants. Rate of a reaction changes with change in concentration, but the value of rate constant is always fixed and it do not change with change in concentration of the reactants. Okay, and then let us discuss what is molecularity and what is order and differences between them. So in a balanced chemical reaction, the number of species which are reacting is known as molecularity of that chemical reaction. That means the number of different molecules which are reacting in a particular chemical reaction is known as molecularity of that chemical reaction. Again, the sum of the exponents in the rate law expression is known as order of that chemical reaction. That means earlier we have discussed alpha plus beta equal to n, and that n represents the order of that chemical reaction. And again, molecularity of a reaction cannot be zero. Okay, molecularity is always whole numbers. Okay, but order of a reaction can be zero. So when order of a reaction is zero, then that chemical reaction is known as zero order reaction. And then when the order is 1, then that chemical reaction is known as first order reaction. And when the order of a reaction is equal to 2, then it is known as second order reaction. After that, the molecularity of a chemical reaction can be obtained from the balanced chemical equation. It is always theoretical, but the order of a reaction is always experimental. In our next classes, we will discuss some numericals, and then you will get the idea how to determine order of a reaction. And then molecularity of a reaction is always whole number. It cannot be fraction or zero, but order of a reaction can be zero or even fraction. Then for complex reactions, that means the reactions which take place in towards 3 steps or more than 2 steps, the molecularity has no meaning. But order of a chemical reaction can be determined for complex reactions also. Okay, that means molecularity is only applicable for elementary reaction. That means those reactions which occur in single step. But order of a reaction can apply for both simple as well as complex reactions. And for complex reaction, the order is equal to the molecularity of the slowest step. Okay, that means there are several steps in case of complex reactions, and among them the slowest step is rate determining step, and the molecularity of that step is equal to order of that chemical reaction. So you have already studied the SN1 and SN2 mechanism in chapter 10, haloalkanes and haloarenes. So in that particular reaction, you have studied about the molecularity and order and their concepts. Okay, applications of molecularity. Okay, unimolecular and bimolecular reactions. So in our next class, we will discuss integrated rate equation for zero order reaction. After that, we will discuss integrated rate equation for first order reaction. But before discussing integrated rate equation, we have to study differential rate equation. Okay, so in our today's class, we have discussed about what is rate of reaction, after that factors affecting rate of reaction, and then We have discussed order of chemical reaction, molecularity, then rate law expression. So in our next class we will discuss differential rate equation, integrated rate equation. So that's all for today's class. Thank you.